last page of the review for Unit 10 exam, all about circles, writing equations, and then graphing. Very quickly, in terms of a review of the equations of circles, the basic formula is x minus h squared plus y minus k squared is equal to the radius squared. A few notes that this value is the opposite x value, and this is the opposite y value of our equation circle. And this is, of course, the radius value squared, so that means that the radius is just equal to the square root of whatever number we would write in there. So that may come up occasionally. So let's go ahead and jump into question number 27. Given the equation of the circle, identify the center and the radius. Well, my center, this is my opposite x value and opposite y value. So that means my center is at positive 3, negative 2. So opposite of negative 3 is positive 3, opposite of positive 2 is negative 2. My radius is going to be the square root of whatever number is listed here. So the square root of 16 is going to be equal to 4. Question number 28. What is the center? Well, I need the opposite x, so that's going to be negative 2, and the opposite y, which is going to be positive 11. For the radius, I need to take the square root of whatever number's here. Square root of 21, not really that nice, so we're just going to leave it as the square root of 21. And we're done. All right, 29 and 30, we are going to go ahead and write the equation of the circle, kind of the reverse now, given the center and given the radius. So we'll start off with x squared plus y squared equals, and same thing on number 30, x squared plus y squared equals. Okay, so when I write it into the equation, I'm given the center negative 2, negative 5. I need to write it as the opposite, so it'd be plus 2 and plus 5. So here, positive 3, negative 6, I need to write it as minus 3 and positive 6 in my equation. Now, in terms of what the value I write in here, as I take the radius and I square it, so 5 squared means that I have a value of 25. Let's do some highlighting here. Now for this, I'm going to take the radius and I'm going to square it, so the square root of 17 squared, try that again. This, I'm going to square my value. So the square root of 17 squared, we talked about this, square root and square root undo each other, so that means that we are left with just a 17. And we would just leave it as such. Okay, 31 and 32, we're not given a lot of information in terms of the center. Well, we're given the center in 32, but we're given a point on the circle, or here we're given the endpoints of the diameter, which are on the edge of the circle. We need to work to find the center and the radius value. So I'm going to start off with number 31. The endpoints of the diameter. Diameter cuts the circle in half. So that means, let's go ahead and actually plot those points. Negative 4, positive 3, and 6, negative 1. So if these are the endpoints of the diameter, if we think about it, I could draw the diameter on there. This is the line that cuts my circle in half. So that means then, where is the center of the circle related in terms of the diameter? It is directly in the middle, right there. Should be my center of my circle. So that means the center should be at 1, 1. Right? Now we can kind of envision the rest of the circle kind of going up here somewhere, right? And kind of down here somewhere as well. That's really not that useful, because really all I care about is the radius. I don't actually need to draw the rest of the circle in. I just need to go ahead and figure out the radius. Well, let's think about this. How is the radius related to the diameter? Well, the radius is equal to 1/2 of the diameter. So that means that this distance right here is actually equal to our radius value. Well, how long is that segment? Well, unfortunately, we can't count it because it's not on the grid line. However, I could connect the center and the endpoint with following the grid segments and basically create a 2 by 5 right triangle, where if I wanted to figure out the missing hypotenuse, we would do, you guessed it, Pythagorean theorem. R squared is equal to 2 squared plus 5 squared. So that means that r squared is equal to 4 plus 25, which is 29, which means my radius is equal to, let's do this. We take the square root of both sides. Square root of 29 doesn't end up being a nice value, so the radius is just equal to the square root of 29. All right, radius equals the square root of 29. Okay, so now I have all my relevant information. What do we do with this relevant information? Well, the whole goal here was to write the equation of the circle. So let's go ahead and do that right underneath. Well, the equation of the circle is x squared plus y squared equals opposite x and opposite y gives me -1 and -1 from above. The radius here, I need to take this and I actually need to square it again. Well, the square root of 29 squared, well, they just undo each other. We're back to just being 29 is my equation. Okay. We don't always have to do the Pythagorean theorem to figure out the radius. Sometimes when I give you the diameter, you can just count the blocks. In this case, I cannot count the distance, so I have to use the Pythagorean theorem, unfortunately, but that's just the way the cookie crumbles. Okay, question number 32. Here we are actually already given the center of our equation. So I'm going to highlight that in blue. And I'm actually going to go ahead and jump down to the equation already. So we already know this is x squared plus y squared. We already know that we have a -4 and a +3 using the opposite values. So we'll go ahead and plot that 4, -3. We are now given another point that's on the circle. So if we plot -3, -5, this is a point that falls on the circle somewhere. So if we think about it, the circle's going to swing out like that somehow. Well, what is the radius value? Well, the radius is just the distance between these 2 points, a point on a circle and my center. How far is that distance? Well, unfortunately, once again, we can't actually just count it, but we can, in fact, create a 2 by 1, 2, 3, 4, 5, 6, 7, 2 by 7 right triangle, 2, 7 with my unknown being the radius. And once again, we can do r squared is equal to 2 squared plus 7 squared. Radius squared here is equal to 4 plus my 49, which is going to be 53. We would take the square root of both sides. 53. That's not going to be nice, so the radius is just equal to the square root of 53. In terms of writing it in my equation, though, I'm just actually going to have to take that square root of 53 and square it. Basically undoing that work there, so that means it's equal to just 53. Oop. Traced all the answers. And there we are. Once again, we don't always have to go ahead and do Pythagorean theorem, but a lot of the times we do. It's in our wheelhouse, something we can definitely do. All right, we're going to end up by actually just doing some graphing. Number 33, the center here is going to be at -1, opposite of +1, and +1, which is the opposite of -1 for x and y. So -1, +1 is the center of my circle. We see that this is my r squared value, so that means that the radius is equal to the square root of this value of 25, which means my radius is actually equal to 5. So we're going to go 5 in each direction. Left, right, up, and down. And from there, we're just going to go ahead and draw in a circle, making sure we're not making it too pointy. Don't want to cut ourselves. And there we have it. We see that we have a radius of 5 happening right there, going up, down, left, and right. Let's take a look at number 34. Same idea here. My center is going to be at +2, -3. Again, doing opposite x, opposite y, so 2, -3. Here then, this is my r squared value, so the radius is equal to the square root of whatever number's there, so the radius here is equal to 3. So I go 3 to the left, to the right, 3 to the left, 3 up, and 3 down, and I draw a circle. You'll note one thing I did here on this. I actually darkened in the outside of my circle. A great way to kind of hide if your circle kind of looks a little lumpy. I can go back in a couple times around it, making sure it's nice and dark. But making sure we're not going too far over. Obviously, we don't want to darken it all the way over to another, make a radius of 4, a radius of 2. But there we are. You can expect to be able to have to graph on the exam along with these other options here in the form of a multiple choice or free response. A lot of times some of the questions will be, hey, here's an equation, and I'll ask you for the center or radius. I'll give it to you in multiple choice form with a bunch of mix and matching. And then same thing with write the equation and finding the center or radius. A lot of these are going to be multiple choice, or especially on an SOL, so please be mindful for that. Great.